So I know I tend to talk a lot about the various Commodore 8-bit machines on this channel, but there's another line of 8-bit computers from the same time period, which I also think are very interesting, and are probably equally as historically important, that being the Apple II series. So let's take a closer look at this Apple II I picked up the other day. This particular model is the Apple II Plus, which is very similar to the original II, but with updated ROMs and a few other minor improvements to the original model. It came out about a year after the original in 1978. But it's not too different from the original in many ways, especially as far as the overall design goes. This particular one is not quite fully original. It does have an aftermarket keyboard, which makes it not original anymore, which sort of decreases its collector's value in some ways, but honestly, that's a bit of a selling point for me. I'm glad it has this aftermarket keyboard, since the original keyboards that came in the 2 Pluses were not great. They didn't feel the greatest to type on, and they were just infamously unreliable. As much as I like my stuff being as original as possible, in this case, I am quite grateful that this has an aftermarket keyboard in it. Here's the back of the machine. Starting from the left, we have the composite video out, followed by a cassette in and out. There's some residue-y stuff here. That was probably from where somebody had stuck like an RF modulator to connect it to a TV. And then we've got these 3 slots where you can route the cables that connect to various internal cards you install. And then we've got the power connector and switch over on the left. Getting inside this Apple II is ironically very easy, especially compared to later Apple products, but even compared to other computers from the time period, there's no screws required. This just sort of lifts off, revealing all the guts. And here are the insides of the Apple II. So down here, you see a bit of a rectangle around this, or a square. These are all the RAM chips. This has 48 kilobytes of RAM. Here's some of the stuff for like the decoding logic and video stuff. Here are the ROM chips. Here's the 6502 CPU. And then up here, we have 8 expansion card slots, one of which is populated with a 16K memory upgrade board, which brings the total memory for the system up to 64K. And over here we got a power supply, a little speaker. Really like these older style circuit boards where like all the chips were arranged on a grid. I think it just looks really cool. A lot of computers of this era had a sort of grid circuit board design. So let's hook this thing up and see what it can do. Okay, so as for the monitor I'm going to use with this thing, I think I'm going to go with this HP 82913A green monochrome monitor. Of all the monitors I have, I just feel that this one suits the machine the best. So I've got everything all hooked up. Let's fire it up. Yeah, that was pretty quick. Anyway, we are at the basic prompt, and the first thing we have to try out is, of course, Control-C breaks out of the program. So one of the main selling points for the Apple II back in the late 70s was it was basically the only microcomputer on the market that had a proper bitmap graphics mode. So let's try that out. Having true bitmap graphics gives you quite a bit of freedom over what kind of stuff you can display on the screen, so you're not just limited to text. So typing in basic programs is cool and all, but if you want to load any sort of software, you're pretty much going to need a disk drive like this. This is an Apple 5 1/4 inch disk drive. It's a little newer than the 2 Plus. This is one of the later 5 1/4 inch drives they had. It sort of matches more with like the 2C or the 2GS, but it'll work with the 2 Plus. If you look at the back of the 2 Plus, there's nowhere to plug the disk drive in. So we need to install a disk drive controller card, which I have right here. It's actually not particularly large, it's fairly simple. And this will plug into one of the expansion card slots. And it's got the connector here to plug our disk drive in. Unlike other systems that take expansion cards, with the Apple II, it actually matters which card you put which slot into. And the disk drive controller quickly goes into slot 6, which is this one right here. And this little slot here is just in the perfect position for routing our cable out the back. And I think this controller card was made more for later Apple IIs, like the IIe, which has like little spots where you can mount these connectors. It doesn't just have like vertical slots for ribbon cables. But if you're using it on an older Apple IIe, it just the connector just sort of dangles loose on this rainbow ribbon cable, which is not a big deal. But if you have one of the later models, you can actually like mount this to a spot. You can mount a port on the back. Here it is with the disk drive all hooked up. So I've got a bunch of disks here with stuff on them. I think the first thing I'm going to try out is VisiCalc. It's on this disk. So I've got the disk in the drive, and I'm just going to power on the computer. You can hear the disk drive knocking a bit. It's just sending the sensor to make sure it's at the track 0. And it's going to auto boot into VisiCalc. So a lot of Apple II disks will like auto boot into the program that's on the disk. And you can set which program you want it to auto boot into. And it's auto booting VisiCalc right now. If you'll remember, I did a video on this a while back, and this is basically the first ever spreadsheet program. It was released all the way back in 1979. When I did my video on it, I was showing off the Commodore PET version. This is the original Apple II version written in '79. It was ported to the PET about a year later. So here's the Apple II version in 40 columns. And as somebody who has a bit of a thing for spreadsheets, I just think this is really cool. There are a couple other things on this disk. We can abort the auto boot by hitting Control Reset when it's auto booting, and now we're in BASIC. To view a directory for the disk, we just type catalog. There's everything on the disk. There's a game on here called Puckman, and Puckman was the original name for Pac-Man. They just changed the U to an A, sort of last minute, because you can sort of like cross out part of the P and make it look like an F. So, unlike the arcade machine, so they didn't want people doing that, so they changed it to Pac-Man. This version is called Puckman, and let's load it. Stuff loads a lot faster on here than on a Commodore 64, I'll tell you that much. Even though it's still fairly slow because floppy disks, by their nature, are not the fastest thing in the world. And this is kind of hard to play without a joystick. Just using the keyboard controls here. And I'm probably going to suck at it. Because there's no cursor keys either, so. Yeah. So use the I, J, M, and L keys to move, which is a little bit awkward since they're not like clearly defined as like arrow keys. But yeah, be better if I had a joystick, which I'll hopefully get at some point. So I've got a color monitor hooked up, and yes, the Apple II can do color, but Apple II Color is a little on the wonky side. If you look up close at some things, especially text, you'll notice it has a bit of a rainbow, and there's just sort of like random colors that appear. And you can notice here in Pac-Man, not all the dots are the same color, and that is because color is governed on the Apple II by the placement of pixels. So you can't control the color for each individual pixel when working with color graphics. You control the color for adjacent pairs of pixels. So putting two zeros next to each other makes both of them black. Putting a 0 followed by a 1 creates two green pixels. Putting a 1 followed by a 0 makes purple. And putting two 1s next to each other gives you white. For each row of 7 pixels, there's a bit that does not control a pixel, but it's actually used to control the palette for the following 7 pixels. If that bit is set to a 1, then 0, 0, and 1, 1 will still equal black and white, but 0, 1 will give you orange, and 1, 0 will give you blue if the palette bit is on. This can be a really annoying limitation to work within because when you start freely placing pixels wherever you want on the screen, they're going to end up random colors. Well, they're not truly random, but you get the idea. If you want a certain pixel to be a certain color, you can't place it in certain spots on the screen. So there is a color killer circuit in the Apple II, which essentially just strips the color out of the signal, so you don't get any sort of rainbow effect on things. When in regular text mode, like the basic editor, the color remover circuit is active, so it's actually like surprisingly clear and sharp looking on this color monitor. But when we enter graphics mode, as you can see, the text goes all kinds of rainbow. See, it's all like rainbow and multicolored. That's because when we enter graphics mode, or really split screen mode here, it turns off that circuit. Taking a closer look at all these pixels in the sine wave, you can see that they're all different colors. When we enter back into text mode, the rainbow goes away. That's because it reactivates the circuit that takes the color out. What's interesting is how these colors appear connected to a monochrome monitor. So going back to that HP green screen monitor again, you'll notice that a number of things on the screen have like this dithering effect where every other pixel is turned on. Now let's connect up that color monitor again. And now you can see they're solid colors and no dithering. This is especially obvious with this fire here. That is because the color effect relies entirely on NTSC color artifacting and some weird quirks of the way that color in analog video signals work. A monochrome monitor will completely ignore that, and it'll just focus on which bits are on or off. So on a monochrome monitor, a 1 is on and a 0 is off, and it doesn't really matter what bits are next to it. And for those of you wondering what the sound capabilities of the Apple II are like, well, it's just a one-voice beeper. So now let's talk about something that's not so great about the Apple II, and that's the basic editor. So let's say I'm writing a little basic program, and I make a mistake. Unlike the C64 and other Commodore 8-bit machines, I could just cursor up, make the change, and hit enter, and it'll update. And the cursor key arrangement to actually move the cursor is not the greatest with this weird 3-key setup, but it's pretty simple just to go up and make changes to your program. Let's do the same thing on the Apple II, and we want to cursor up and change it, but you'll notice there's no up and down cursor keys, only left to right cursor keys. So in order to cursor up, we have to hit escape, which will put it into a mode where we can use the I, J, K, and M keys like cursor keys, and it completely disables all the other keys on the keyboard. And now we can use those keys to freely move the cursor around on the screen. We'll move the cursor up, hit escape to be able to type normally again, and make our change. When we hit enter, it deletes the rest of the line, and it kind of broke the line now. This is because you have to cursor over to the end of the line and hit enter to re-enter the whole line into your program. So that's really frustrating. And oftentimes when programming in BASIC on the Apple II, I just find myself retyping the line instead of trying to edit it, because that's just more convenient in most cases. So what are my thoughts on the Apple II? Well, I think it's a very cool machine. The Apple II feels a bit like a cross between the hobbyist kick computers of the 1970s and the commercial mass-produced computers of the 1980s. The Apple II was a mass-produced product, but it was built entirely out of off-the-shelf components, and there was still a fair bit of emphasis on tinkering and hacking. Well, it's definitely not the most capable 8-bit system around, especially when you compare it to later machines like the Atari 400 and 800, as well as like the Commodore 64. And when you consider this all came out back in 1977, and was made entirely of off-the-shelf components, it's actually pretty impressive. The Apple II blew the Commodore PET and TRS-80 out of the water in quite a number of areas back in the late 70s. All in all, I really like my Apple II, despite the fact that I'm a pretty big Commodore fan, and you'll definitely be seeing this machine again on this channel in the future. But for now, as always, thanks for watching and have a great day.